my name is Cameron Skinner. I'm the Visual Studio Ultimate General Manager. I've heard the joke, yeah, you must be the Ultimate GM. Yeah, I've heard that 1,000 times. My team is actually really sick of that one. What I do at Microsoft, just to give you a little background, is I run one of the product teams here that is responsible for little features in Visual Studio like the debugger, IntelliTrace, a lot of the visualization tools, modeling tools, the profiler, a bunch of these sorts of things are under my responsibility. The developers and program managers and testers kind of report up through me, so it's kind of my responsibility there. What I'd like to do today is actually have a conversation with you all, because we actually, there's quite a few folks, but it's more about the room here, so I think we can have a conversation versus just me talking directly to you. So if you have questions as we go, feel free to blurt them out, interrupt, ask as we go. You won't hurt my feelings, and in fact, I prefer that. I much prefer having a conversation versus just presenting. So what are we talking about today? The abstract here is architectural renewal. What is that exactly? I kind of like to talk about architectural renewal most from a perspective of manipulating existing software and talking about the challenges therein. I'd like to understand who I have in the room, though. How many folks are actually developing code, actually writing code in the room? Okay, a few folks. The other folks are managing development and engineers. Okay. Any testers or test managers? Testers? Excellent. I did a keynote at VS Live last month or so, and I think there was one guy in the audience was a tester, and boy, he was a tester, this thing, because he's like the only person there, so that's good. I want to have a conversation with you guys around how often do you get a chance to create new projects? So with the show of hands, how many people actually get to feel the experience, file new project? Okay? A few, more than I thought, actually. So the rest of you are dealing with existing code bases, yes? Yeah? And give me an idea in terms of how old some of those are. Just throw out some numbers. 12 years? 1981. Can anyone beat this one? 1981? Okay. That's a decent longevity of some significant software. That's good. How big is that source base?
When we translated it to C#, it went up to 4.5 million
4.5 million
lines.
lines. Okay. Excellent. Size of code here, 4.5 million lines. Anyone can beat that? No? Oh, there we go. There's some hands. 6 million? And how is that? Tiring? So 6 million lines of code. How's that? How many engineers do you have on that? 35 folks? How long does it take you to bring up a new engineer on that base? So, welcome to the team. Here's a nice meaty piece of code for you, that kind of thing.
Months to be productive.
Months
probably.
before they're productive.
Yeah.
How about you, sir?
Well, about a year and a half before they can take a page without calling somebody.
A year and a half before they take a page. Okay, good. So this is what I want to talk about. I want to talk about the challenges around changing software. And kind of why we do it. And I kind of wanted to start there. I've got a very funky setup, by the way. I've got the presentation over here, but my machine is presenting here. So you'll see me doing this thing, which is going to be exciting.
I'll get another one.
Why do we change software? And has anyone read the Michael Feathers book, Legacy Code? Michael Feathers book? It's a fantastic book. If you haven't read that, highly recommend reading that. I essentially lifted some of the things that he was talking about in that book for this slide here, in terms of why do we change software. And we change software to add a feature, fix a bug. Some organizations, it's kind of the same thing. Adding a feature, fixing a bug, you can do kind of the same amount of damage, depending on how you go about doing that, right? But then, you're also going to go change software to optimize resource usage. So, hey, we're leaking memory, or we've got some performance problem, or what have you, okay? You could say that's a bug or whatever, but I think it's interesting to just call that out. And then there's one to improve design. So to improve the maintainability, perhaps, of that source base. And I wanted to call this out and read this, actually. So, why improve the design? To make changes to code easier and more predictable, right? That sounds good. So why don't we do that more often? Well, one of the main reasons why many programmers don't attempt to improve design often is because it's relatively easy to lose behavior or create bad behavior in the process of doing it. So this is the typical thing where I get in the source, I make a change, and now something else breaks. Right? So engineers have a tendency to not want to do that, or they're fearful of making changes in code because maybe they don't have the test infrastructure. Maybe they don't have an understanding of the dependencies. Maybe they're working on a code base that's 6 million lines of code, and they can't possibly keep it all in their head, so they don't quite understand what's going to happen there when they touch that code. Okay? Again, though, why do we do this? So this sounds hard, it's scary, and it can cause some significant pain. And fundamentally, what I want to point out is that we're changing existing software in an effort to maximize the return on that investment. And I don't mean literally, hey, I put $10 in and I want to get $20 out. Although, depending on your org and depending on what the software is doing, that may, in fact, be kind of what you get. But it could be everywhere from, I'm a software artisan, I'm a craftsman, I just want to make this thing as good as it could possibly be, so I'm going to get in there and manipulate that source base. Okay? Hey, I'm a consultant, so I'm hired to go in there and do this, so I'm doing my job, etc. But fundamentally, this concept of making a change in order to get the return on that investment is an important one, and one that if we think, generically, I'm putting a bunch of time, I'm putting a ton of effort into this source base, and I want to get something back out of it. We've got to solve a real business problem, and I want to continue to see that business problem being solved day in and day out. Okay? So you'd think that, the longer my code is there, the greater the return, and you would think that, right? Some of these gentlemen, 1981, sir, are you still getting the return on your investment there?
Yes.
Okay. So that was a yes, yeah, and that's good. And if it wasn't there, you still wouldn't be putting up with that code base. I want to say here, though, maybe, right? Good over here, sir. You got 6 million lines of code. How's that going? Good. It's still there. Good. Some folks who have, the longer the code is being manipulated, the more chance that code starts to smell, starts to break down, starts to look a little like perhaps something like this, right? Where you've heard some folks talk about my software architecture is the big ball of mud. And every time I go in there and attempt to make a change, I break something, right? And so my ability to maximize my return on my investment is starting to deteriorate, right? I'm having a hard time because I'm starting to actually have to spend a whole ton of money and time and resource in order to get, even a sliver of goodness out the other side, right? And so I want to talk about this situation here. What do we do about it, right? And what are we doing about it? And and I don't want to have a conversation about best practices, et cetera, et cetera. I'll get into some of this. But honestly, I want to talk about some of the options that we have as an engineering organization when we start to experience the big ball of mud phenomenon, or we start to experience friction in our ability to get something done with our existing source base. Okay? So we have a couple options. Okay? And honestly, the couple options kind of look like this. Option one, light it on fire. Start over. That's real, right? How many folks have been involved in a re-architecture project? Lots. Lots. Okay. And of those folks who were in a re-architecture project, how many came out the other side with a completely different set of problems, but essentially the same kind of problems?
This one where nobody wants to raise their
Yeah, no one's like, oh, we did it right. There you go. That's very good. If that's really honest, only a couple folks raise their hand. That's excellent, actually, in terms of percentage. That's excellent. What we've been seeing is actually the classic case of the, grass is always greener on the other side. Man, if we would just throw this thing out and start over, nirvana, right? And the thing is, folks don't realize, and I know that most of you do here, although a lot of people have taken this, bit this bullet, is there's risk involved, clearly, in doing that, right? If you didn't learn the lessons of the past mistakes in terms of how did we get to the point where we just lit this thing on fire, then how do you know you're not going to do that again, right? So then the other option here, to be simplistic about this, is we attempt to understand your existing base in order to manipulate it, in order to leverage it, fundamentally to maximize that return on your investment, okay? And that's what I want to spend the rest of the time talking about, is some techniques and some strategies around how do you take that existing base if and when you decide to not light it on fire and you want to move it forward. There's some interesting things, though, around these two options that I don't want to just say the first option is just not an option, and a few of you have already discovered this. There may be real reasons why actually that is the right option, right? And it's important to understand when those characteristics are presenting themselves. Things like it truly is impossible to make a change here without breaking something. It's truly impossible. We can't understand the characteristics of this code base. We don't have a test infrastructure in place to understand what the behavior is supposed to be. These all kind of conspire up to perhaps indicate to you that, man, maybe you should start over and do things right. But it's important to understand why you would do that versus, your engineers and your developers, even the best intentioned, I'm telling you, will want to light it on fire, right? Because file new project is fun. And it's a heck of a lot easier when you're on a project from the start and you get to push it through, right? So that's real. So let's talk about some of these techniques. And I want to talk about this in terms of, clearly I want to show you some Visual Studio stuff. And I want to show you some stuff in terms of what we have around understanding your source base. And I also want to talk about, I want to show this to you in current tools. Because I know, I'm sure we've been showing a lot of the newer product, Visual Studio, what we're calling Visual Studio 11. But I actually want to show you, to make sure that you understand some of the tooling that we have in Visual Studio that you can attribute to some of this or apply to some of these problems that's in market now that your teams are using. How many folks, how many teams are actually using Visual Studio 2010? Awesome. Okay, that's really good. How many of those folks are using Visual Studio 2010 Ultimate? Wow. That's fantastic. Okay, great. So everything that I'm going to show you, you have. How many people who have Ultimate today actually understand what like DGML graphs are? Couple. Okay. Yeah, Peter, that's good. You're on the team. That's good. Okay. Okay. And how many people have seen layer diagram? Okay, a few. How many people are actually using like the layer diagram in their production now? A couple. Okay, good. So I want to talk about some of how some of those tools right there are going to be applied to this particular problem. Okay, and I want to spend most of the time actually kind of showing how to use some of those tools. So of the folks that raise their hand and haven't seen some of these things or don't know what I'm talking about, are those the management types? Are your teams using the dependency graphs? How many folks are actually using that piece of functionality? A little bit? Okay. Okay. All right. So let me show you this. Let's start talking about what this can look like. Okay. So now what I'm going to try to do is I'm going to demo by looking over here. Okay. Can everyone see that in the back? Okay. If not, I can do the get you motion sick here. Okay. So what I have here is a simple project. Okay. And here's the thing. I don't want you to take this. It's hard to do these demos with 6 million lines of code. Okay. I've got a small project here, but I just want to show you kind of what you can potentially do, and I actually do want to talk about what you can do with a big base. With that 6 million lines of code, are you loading that in a Visual Studio solution? Really? So you've broken that down into, the answer was sometimes. You're breaking it down into multiple solutions, that kind of thing?
Yeah, but sometimes you want to refactor across.
Right. Right. So sometimes you need it in order to take advantage of some, like, if you're going to do some big change, like a refactoring. Okay. All right. How about you, sir? You've got 4 million lines of code. How do you load that into Visual Studio?
No, we have some solutions that make up as much as a fourth of it.
Okay. Okay. So you guys are already starting to break it down. As you would expect. Okay, good. So I do want to talk about, although my base here isn't huge, I do want to address how could you use some of these techniques in some of those larger bases. All right. So what I have here is a simple web project, and what I want to do is I'm going to go up to Architecture, Generate Dependency Graph, and I'm going to do this dependency graph by assembly. And what I want to do here is I want to have Visual Studio kind of build my project, make sure it builds. Then I want it to go and analyze the output of that build process. So whatever those projects are building, it's going to result in some DLL or maybe even an exe. And I want to understand my dependency graph. Okay? Turns out that a lot of the complexity in software development is around dependency management or the lack thereof. A lot of times it's when I'm changing a piece of code, it's not because I meant to go break that thing and take the server down. It's because I didn't realize that I had a dependency, that thing over there had a dependency on the code that I just changed. And that's a dependency problem, right? So in the 2010 product time, we basically went in there and said, we got to start solving this problem. This dependency management problem is really painful. How do we start to apply these techniques of understanding your dependencies and apply it to legacy software? And when I say legacy software in this sense, it's really any code that you wrote yesterday, even, right? Any existing software. How do we start to get this stuff under control? When you fire this piece of this tooling up on your project, you will notice down here, let me zoom in here. I'm going to hold my control key and just use my mouse wheel. I'm going to zoom in, drag this up. And you'll see this externals box. And one of the things that we really wanted to make sure that we understood is that we didn't want to just show you what you could load in an assembly. We wanted to make sure that in a solution. We wanted to make sure that you understood what your code that you were writing was dependent on. Because a lot of folks are dependent on third-party software, right? Be it open source or be it some third-party component, you're dependent on some other services that you didn't write. Or maybe some other parts of the organization you're depending on, but the bottom line is you didn't write that code. So we wanted to give you the ability to understand what your software is depending on or built upon. Okay? And this is in itself very important to understand the foundation that your software is built on, right? So for instance, if I start to drill into this code here, wrong machine, I click on this chevron, and that'll expand. And what I'm going to see here, these blue boxes represent DLLs, okay? And what this is showing me is these are all the third-party DLLs that this piece of software is dependent on. And this is any DLLs. This is the framework DLLs itself, like the .NET framework DLLs, or any other third-party software is what you see here. Now, I'm only showing you what it's dependent on. So I'm not showing you everything in the .NET framework in terms of all the DLLs. I'm only showing you dependencies that your code in this particular solution is dependent on. Okay? I can go farther, and I can start to analyze, okay, really we're using system web DLL, so most likely this is a web project. I'm going to select that, and as I do, you'll notice these light blue, they show up a little light on this monitor here. But you'll notice these dependencies start showing up. I actually want to drill into this and drill into that assembly. And so now what you're starting to see, these little blue boxes here represent namespaces. Okay? And it's not every namespace in that assembly. It's only the namespaces that you have a dependency on. Okay? I'm going to keep talking about this because this data filtering thing, we don't want to overload you with too much data. You know, you've already got a complexity problem with your software, especially 6 million lines of code, 4 million lines of code. You know, we don't want to overload you with data. So we basically want to show you, look, you're just dependent on these particular assemblies and these namespaces. And in fact, I can even drill deeper into that and say, okay, system web UI web controls. Okay, cool. So what am I dependent on there? And now I'm starting to drill in to the actual classes or types that I'm dependent on. Okay? And from this perspective, if I wanted to, like, you've got a list control here. If I select that, notice I get a link here that shows up, and it's showing me a dependency back out to my source. If I hover over that link and click to the other side, it'll actually drill into my source base to show me exactly where I'm using that list control. And in this case, I've drilled back out into my source. I've jumped into my PetShop Web DLL, into the petshop.web namespace, into my checkout class, to the method, I can't read it from here, get credit card info is using that type. Okay? So the idea here is understand, you know, the dependencies here. As I jump back here to that method, you're seeing incoming and outgoing dependencies so that you can get a sense of what this particular chunk of code is all about. What is it potentially doing when you in fact need to go and change it? Does that make sense? For the folks that have Ultimate, have you seen this? Couple. Okay, good. All right. If everyone had seen some of this, I'd just stop and we'd be done. Okay, good. So now what I want to drill into a little bit more here is this is a snapshot of your code at this particular point in time. Okay, I can actually go into the code base from here, and I can also search through this to find you know, something specific. Like for instance, let's say I wanted to understand how we were inserting products or something. Let's say this is a you know, a web cart-like app. So I can go into the app, and in here I can hit Control F, and cool, it shows up on this other monitor. Okay, there we go. And then I can type in insert, and it'll take me and find all the various spots in my diagram where I am finding where I have an insert method. And here I've got in an asynchronous order, I've got an insert method. I'm going to say find next. I've got an iOrder interface here where I've got an insert. I'm going to do next, okay, and so on, right? So I can really dig in and figure out whether or not those are the areas that I want to do. So now, at this point, I can also just double-click, and it takes me to source, okay? I actually want to I'm going to hit Control minus. It takes me back to where I was. These are all just Visual Studio you know, gestures. And I'm going to go, I actually want to go into this one. I'm going to go into this guy. And at this point, I can come in and say, okay, I'm getting an idea of some of the dependencies that I've got in this source base. But what I don't understand, I've got the raw understanding of okay, this is using that list control, let's say, or this is using these other types. I've got a general sense of the potential impact I could have if I make this change. Okay. What I don't understand is when I'm looking at this particular chunk of code, kind of what does the message orchestration look like? What is it? How is the behavior here? What does that essentially mean? What does it look like? How, if I'm going to change this, what am I talking about before I go and do so, right? Well, I can right-click on this. I'm going to close this thing, and I can right-click in this chunk of code, and I can say, hey, generate me a sequence diagram. Anyone doing UML modeling? Couple. This is using UML syntax in order to, syntax meaning notation, in order to use the standard notation to get across these concepts. But bottom line is here, I can say, I need to understand what the message orchestration looks like. And boom, here I am. I've got a picture, a graph, of what this code is doing right now. Right? It's a snapshot. But why is this interesting? Okay. Well, it's interesting because I may need to, I need to get my head around those dependencies. I need to get my head around what this source is doing. Hopefully I have tests. Fundamentally, your safety blanket here is tests, fundamentally. But now I need to contemplate a potential change here that I could be shaking the earth a little bit here because of my understanding of the dependencies. So at this point, maybe I need to have a communications. I need to talk with my team before I actually go and affect code. And so what you can do is you can come in and say, all right, look, I'm contemplating a change, and that change is going to start here, and it's going to do that, and then it's going to come over to this object here, and it's going to come back, and then I'm going to call this operation, which is going to come back. And you notice how I'm showing it looks different. And the idea here is I'm starting to be informed by the code as is, and I'm starting to contemplate a to-be state. So I'm starting to say, I need to change this code, and I want it to potentially look like this in terms of the handshakes between these types. And at this point, I can take that and give it to some of my other team members, right? And we can have a conversation about it before I actually even have to go write code. Okay? Does that make sense? When you guys are going through and you're contemplating making a significant change in your source base, what does the process look like? Anyone? When you are sitting there thinking, okay, we need to make a change at the heart of our system, what do you do today? Whiteboard. What else? Did you say cut a branch? Yeah. Cut a branch. Start to experiment. Yeah.
See what all is affected by the change.
Say again.
See what all is affected by the change.
And so he said see all. Oh, by looking at this, see all that was affected by the change. Oh, okay. I thought you meant just make the change and see what breaks.
No.
And hey, folks do that too. What else? Say again? Collaborate in what way? How do you do it?
Knowledge experts that are in that area really looking at and trying to gather the group of people who understand all the touch points.
Okay. And so this is great. So get all the people that know the code and start having a conversation about, hey, should we make this change or not? Either on the whiteboard, using this kind of tools or what have you. Yeah. Okay, great. So this is great. So what I'm trying to emphasize here is there's many tools. These are in Visual Studio I want to make you aware of. This process of understanding your dependencies, I think, is extraordinarily important. Having tests is also extraordinarily important, and we can spend a whole nother talk just talking about the importance of testing and tests in your code. But I want to get an understanding from you. Am I on the right? Is dependency management, was that one of your biggest problems? When you talk about the last big bug, big shaking issue in your source base, give me an idea of what was the root cause? Anyone?
traceability. Oh, thank you. That there's some metrics that shows the coupling and the cohesion of those dependencies. And it would be nice if I could go through and say, give me the top 10 that I need to go look at, instead of seeing a visual that, and if I got a million lines of code,
Sure.
that visual is not going to really.
So you're saying use some code metrics.
Yes, without me having to write a little tool to go in there and inspect the modules and iterate through that. Do
Sure.
you already have something that's that?
Sure.
Can
Okay,
you give me some?
that's another approach. What else? Go ahead.
Traceability. It's not always clear when people testing the system, when you make a change in the underlying code, what parts of the system you need to retest from that.
Okay, so traceability. So, all right, great. So this is a good one. So after I've made the change, we've got everybody in the room, and we've contemplated what it should be. We make the change. Now, what does that look like in terms of test coverage, in terms of other code that is being impacted, et cetera? Okay, good. So the idea here is, though, understand these changes, understand the dependencies, go in and make the change. And one thing I do want to emphasize here, because I don't want to overemphasize the fact you need to do all these things before you make a change, right? Meaning, if you have tests in place and you have appropriate processes in place, this may be perfectly valid to just make the change and then have your test bed, et cetera, tell you whether or not that is accurate. Okay, we could go all the way over to the left and say, boy, be very scared about making a change to your software because bad things can happen. And I don't want you to hear me saying that. I want you to hear me saying these are complicated issues. Here are various number of tools that you can use to get those under control, and just do so. A number of customers that I've run into actually go in fairly uninformed in terms of what their system is actually doing, and then they're surprised when the server light's on fire after they checked in. That kind of thing. Okay. So let me switch back here, and so this understanding the code part of this is key as we've been discussing, and fundamentally, it's about reusing those assets and being able to move them forward. So at this point, you now have a better understanding of your dependencies. You're actually in there making some changes. Okay, but then what's the next step? Like we're one of the. How many have heard of the concept of software atrophy? Right. Over time, software tends to go bad, right? And we've just discussed some of the major reasons for that is dependency mismanagement or what have you. But how do we get it under control? Now I understand it. Now I can get in there via whatever techniques, these techniques or what have you, and I understand it. But how do we keep it under control, right? How are you guys doing that now? When you get into you collaborate, you guys make this change. Awesome, you guys having these things, and then maybe some folks in the team go away, they're doing some other things or what have you. How are you making sure that your code is staying solid and you're keeping the smells out? Are people using like unit testing frameworks to do some of this? You're not doing this? Go ahead, unit testing, okay? Anything else? How are you guys keeping these things under control? I can tell in the last talk here, by the way.
Behind you.
They keep a very expensive guy who's been there for 10 years. He's the knowledge base.
Okay. So one human is walking around with all the tribal knowledge. Okay. That gets expensive. Okay. What else?
What we're trying to do is get some test automation. We're doing a lot of effort into some test automation.
Okay.
Now, whether or not that will come to fruition, but at least it's reducing the time it takes us to get that cycle time so we can tell much more quickly, based upon some changes we've made, whether we've broken anything or not, rather than doing so much manual testing. We've actually added some APIs into the code that will help us
Okay.
do more of that automation testing. So that's one of the things we're doing.
Okay. Okay. How many folks are doing automated testing, functional testing? Okay. Okay. Any other major technique that we haven't mentioned in terms of keeping stuff under control? Because I want to show you another. Go ahead. Bug review, you said?
Code review.
Oh, code review. Certainly, certainly. In terms of on check-in, you guys have a code review process upon check-in?
Yeah.
Sure, that's another really good one. Okay, let me show you another.
Cameron, we have another one.
Oh, go ahead.
This is a little bit of a strange one, but we just implemented a check-in policy that the number of lines, you can't make it more.
So, say again?
So you're changing a method, you can't make it more lines.
I have not heard that one. That's cool. So bottom line is you got to break your method down, refactor that thing. Okay. Okay. All right. Let me talk about another one. Folks have seen layer diagram. A couple of folks have raised their hand here. A couple of folks have actually tried to. A couple of folks sounded like they were using that in actually taking that out and using it in production. Couple. Okay. The idea behind the layer diagram is you take that understanding of your source and you start to assert some design constraints on it. Let me show you what I'm talking about. And the idea is, keep this thing under control by kind of like codifying those constraints such that every time I build, I can understand if those constraints are being violated. And this is, again, back to dependency management. Let me show you what I mean. In this project, I've got a layer diagram already in place. Let me show you that. Oops, wrong one. Okay. And let's see. Let me zoom this out here a little bit. Let me full screen this. Okay. Now, I know you can't see the text here, but it's actually unimportant. What I want to show you here is how many folks, you've got 6 million lines of code. This gentleman's got 4 million lines of code. You go up to the whiteboard, like this gentleman was saying, and you do some boxes and lines. And no matter how big the base, somehow it always comes down to, yeah, you see those 6 boxes in line? That's the architecture. That's what we've just spent the last 10 years building, right? We actually wanted to support kind of that concept of big box kind of architecture and being able to kind of feed that into this dependency management scheme. And what I mean by that is you have a box up there that says, okay, there's my UI. And my UI talks to my business logic tier, let's call it. Okay, so there's 2 separate tiers. And my business logic tier talks to my data tier. This is a classic breakdown, right? And dependency should flow down from that, right? My UI depends on the business tier, which depends on my data tier. And I shouldn't see my data tier depending on the UI tier, okay? But how do you know? Until you go take a look at those dependency graphs, or you get the one human who has everything in his head in the room, or what have you. We wanted to give you the ability to actually codify that intent, that design intent, into a layer diagram. Okay? How do you do that? You basically come in here, and you basically drop in a box, so you can draw this, right? A simple box that represents, like in this case, I'll just zoom in here so you can see. In this case, I've got a web. There's my web tier, okay? And what I'm saying is, hey, I've got my web tier can depend on the domain model, and it can depend on my business tier, and it can depend on my cross-cutting tier. Okay, that's great. You're now actually starting to define what your dependency flow, your outgoing dependency flow looks like. But Visual Studio has no idea what you mean when you say I've got a web tier or a business tier or what have you. You have to teach Visual Studio what it is. And so you can do that in a number of different ways. You can drag and drop off the Solution Explorer here. Let me get out of full screen mode. Literally take a couple projects, and you can drag them out on there and let go. And what that'll do is if I show the Layer Explorer, is it will show you what code in your project is making up that layer, okay, that tier. So in this particular case, I'm saying, hey, down here, you'll notice Pet Shop Web. Let me zoom in on this. You'll see right here, it's saying, hey, the Pet Shop namespace is what we mean when we say web, okay? Now, I can also drag, classes onto there. I can drag namespaces themselves, etc. But fundamentally, you teach Visual Studio what it's doing, okay? And then at that point, we can go do a dependency check, all right? And so that's what we mean by that is, all right, you've told us what the dependencies should look like from a high-level kind of design architecture point of view. Now, please go validate that. And so I'm literally going to say, right-click, validate architecture, okay? And what Visual Studio is now going to go do is it's going to do exactly, it goes through the same process that I did when I did a big assembly diagram earlier in the talk. It's going to make sure your project builds. It's then going to go and analyze all the assemblies coming out of your project. Then it's going to analyze all the dependencies. But then the extra step that it's going to do is it's going to say, all right, given the constraints that they have now put on this diagram, is it violating anything? And I want to show you what it looks like when you do. So let me make this a little bigger and show you. We'll zoom in here. And basically, you get an error, just like you would in a build if you had a compile error, that basically says, hey, you've got an invalid dependency based on the diagram that you just drew, right? Okay? You've got an invalid dependency. You've got an insert method here that's depending on this authorize method, okay? Okay, great. So now I've actually kind of discovered, let's say we got all those people in the room, looks at the code, looks good, right? Then you actually code it up, but you had it inadvertently took a dependency somewhere on the code that you hadn't anticipated. Now what do you do, right? Well, a couple things. You could, right-click on this thing, and you could suppress it, right? Make it go away. I don't want to look at it. Out of sight, out of mind. That's one way of dealing with it. You could create a TFS work item from here and assign it to somebody else on your team. Not my problem. This is Bob's code. That kind of thing, right? You could go into the code to understand what happened. Why did I get this violation? So I could go to either the layer diagram itself, and it highlights the two layers that we've actually detected a dependency between this one and this one. You'll notice there's no line there. And we've just discovered that that's invalid. You could draw a line there from that one to that one and call it done. But probably not what you had in mind. Or you can go into the code, like I was saying. I can right-click on this thing and say, go to either side of that dependency. So I can go to that order insert method and jump into that and find exactly where that dependency is happening. Okay? That's cool. So now we can start to actually drill in and really understand, look, what is going on here? But here's the thing. A lot of times, especially if you're talking about a big code base, you could come up there and you could describe this, your intent. Here's the architecture that I want, right? And if you do that, most likely you're going to get quite a few of these errors pop up, okay? So how do you deal with that? Well, I mentioned that you could suppress. One of the things that you could do is use this particular feature here to do a kind of an incremental re-architecture job. Meaning, you draw a diagram of the architecture that you want. You validate that architecture, and you get, sure enough, 1,000 warnings, 1,000 errors. Okay? You basically then say, all right, I'm going to suppress 900 of those, and I'm going to keep 100. And I'm going to create work items for each of those. And I'm just going to eat this elephant one bite at a time. So I'm going to fix those first few errors, dependency errors, and I'm going to move from there. I'm going to unsuppress and continue, right? That kind of thing. Question? I'm sorry, I can't hear you, sir. One sec, we're going to get you mic.
Sorry. If I had a strict architect and I did not want the violation to be if I initially created my layers from the very beginning and I had the basic presentation, business, yada, yada, yada.
Yeah.
And then I went through and the developers, I did not want them to violate it. Is there a way that, and it may not be now, but maybe later, or something to think about, where they could not call from the website or the UI down to the data tier?
Yeah.
In other words, I can't drag and drop, or even if I attempt to put that object or use that method in a data tier,
Yeah.
I can't do that. It won't allow me. It'll give me an error. Without having to go through this process, this stops them right from the get-go.
I see. I think the closest thing you can get there is to draw the diagram and get it in your build process, and it would catch it right when they did it. We don't have anything that would prevent you from actually writing that code, I think is what you're asking.
Right.
Yeah, exactly. So this gentleman here just said something. The thing that you could do, because you can get this part of your build process, okay, is you could include that as a step in your build process. I mean, your gated check-in, right? So such that are everyone familiar with gated check-ins?
So I write an I change policy or whatever that.
No, it's easier than that.
Okay.
It's easier than that. You go and you create a build definition in Team Foundation Server, and you basically say, I want a gated check-in, and every time my developers check in, it's basically going to create a buddy build over here. It's going to pull down latest code. It's going to apply that change set, and it's going to run all your tests, let's say, or layer validation.
Right.
And if everything passes, then the system will check in on that developer's behalf. But if it doesn't, and it fails like this validation pass, it doesn't check in.
Okay. So.
Yeah.
All right.
Thanks for that.
Thanks.
I got a question here. I am. Here I am.
Okay, there you are.
I'm wondering if this wouldn't solve the issues that we're trying to address. One of the issues we've got, and I think this is similar to what he's addressing, is the fact that a lot of our user interface code, a lot of our very high-level UI code is calling directly into the database, bypassing all the APIs that we want them to use and going direct to the database. So if I'm understanding correctly, this should help us narrow down where they're calling directly into the low-level DLLs to get that.
Yeah, it would. So you would basically draw the architecture that you want, right? And then you would basically, by the lack of a link between your UI tier and your data tier, you're implicitly saying to the system that is not allowed, right? We've actually had a number of folks ask us, hey, I want to not link. I want to be able to say this can't happen, And we've got some rules in there where we can say no namespace dependencies, etc. But that would do it. Go ahead.
Is it possible to check the layer stuff when you do the add reference to a project?
Good question.
Then you can stop this in the first place.
That's a great question. So did everyone hear that? Basically, can we have the add reference actually kick layer validation and stop it there? No. It's a great idea, but no, we don't have that capability.
So we started using this layer diagram a few months ago, and it was a big new feature because otherwise we would be writing down the boxes on a paper and then hoping the developers to check it every now and then. So then they decided to do a refactoring on the system, and they decided to start using dependency injection. And then I lost control again and start to happen the old problems.
Yeah.
So do you have any, advice to deal with that?
Yeah, that's a good one. Yeah, because one of the things that, for full disclosure, like this system that we're talking about in terms of dependencies, we're detecting, this is a static analysis, so to speak. You'll notice I'm not running the application. So if you are dynamically loading, like in a dependency injection case, we're not going to necessarily catch that, right? And so that's one of those things where we'd actually have to write a little extra code to make that work. But by default, it's not going to. I'd have to talk to you offline in terms of strategies to go on after there. But that's something to be aware of. This for sure. Yeah. Okay. All right. So the thing that I'm not going to show you here, and that we touched on, you saw me right-click and say validate architecture from the designer, and that's all cool. The thing is, what's most important, I think, is that you can incorporate this into your team builds, so you can do the gated check-ins, and then you can put this on a nightly, right? And you can get this kind of validation, during your, like, if you're using continuous build or what have you. Okay, it's another way of staying clean. Okay. Okay. All right. So let me bounce back out to slides. Where's my mouse? There we go. Okay. And I showed you the layer diagram and validation. And one thing I didn't tell you on this one. That layer diagram validation is implemented with custom MS build tasks. And the reason why that's also important is, let's say you aren't using Team Foundation Server's build system, but you are using MS Build for your build pipeline. You could use this in that situation as well, because we've got custom targets that you can actually use to pass in into this validation mechanism. So you literally pass a property validate target, validate architecture equals true, and then we will detect any layer diagram that's in the system. And you can have many layer diagrams in the system. Just FYI on this. Okay? Okay. Almost out of time here. Okay. So, just in summary, architectural renewal is about, successfully getting your architecture under control. Is all about that return on the investment. And I've just touched on some techniques, and the room talked about a bunch of techniques. So there isn't any one silver bullet. I would be remiss in telling you, hey, buy this product and this tool, and all these problems are solved for you. This is clearly a combination of process and tooling to attack this very complicated problem around architectural renewal and moving existing software to the next level. Okay? So with that, that's all I got for you, and I can take more questions if you'd like. Go ahead.
Yeah, can you just touch quickly on under the understanding domain category you had, the modeling project and Explorer?
Yes. So one of the things that I didn't have time to talk about here in terms of understanding the domain is if folks are doing like UML design, for instance, or any kind of design like that, that would be a way of understanding your domain. So we do have in the product, you notice that modeling project, you have the ability to model your domain using UML notation. And that was new in Visual Studio 2010. Yeah. Yeah, question.
I don't know how many lines of code we have in our legacy code base, but an awful lot of it is in SQL Server.
Ah, yeah.
Can we do any of this?
Nope.
Didn't think so. Thanks.
Yeah, this is one of those things. So when I first got to Microsoft, my first job here was to build the Database Professionals product. And this was exactly the kind of thing that we had envisioned. Like, oh, imagine a world where you could version control your data tier and version control your app tier. And we started really talking about the holistic app, and it's really the behavior and the data all together. And imagine if I could change, a column down here, and I wanted to refactor in the data tier or change a stored proc and understood the dependencies up into wouldn't that be fantastic? And we were all excited, and we never got to do that. Yeah. So, yeah, we all kinds of ways to get better. Oh, there we go. Another one.
Yeah, quick question. There was a seminar that was talking about code bubbles.
Ah, yeah.
When do you think that'll be coming in Visual Studio Ultimate at any time soon?
Yeah, sure. So code bubbles. So has anyone seen the debugger canvas work up on DevLabs? Okay. So this is an interesting piece of work that my team, MSR, and actually Brown University collaborated on to take the Code Bubbles idea. Has anyone seen the original Code Bubbles video? No? Go look at the Code Bubbles video. I think it's on YouTube. The guy that was actually doing that work is actually on my team now, Andrew Bragdon. And then what came out of that was debugger canvas. And basically what we wanted to do, the idea here, folks, for those that haven't seen this, is let's talk about code on a surface and start to visualize interaction with that code as you debug. So as you start stepping, bubbles start to show up, and you start to see this. You really have to see it. I'm doing a hideous job here to really show you that feature. But we're testing out this idea, and that's why it's up on Dev Labs. So to address your specific question of, hey, when am I going to see that in Ultimate? I don't know yet, because I don't know if it's actually this approach is actually going to work. And if you guys, I could really use your help, collective help, to give us the feedback that we would need to say, yeah, you know what, you're onto something. However, don't do blah. Do blah. And that'll help us. But right now, it is up there on Dev Labs because it's kind of a proof of concept. It does install into your Visual Studio 2010, and you can turn it on when you F5. So as you step, you can see code bubbles in debugger canvas in action. That's where we're at. What's that?
One more question.
Yeah. Where is it coming from? Oh.
I had a client who they liked the idea of all the sequence diagrams, but they wanted to know if they would auto-generate when classes were changed. So they said, okay, this is great. You've got your sequence diagram to save. You can check it in. But then when someone changes the class, they want to be able to reopen that sequence diagram and see the changes, and they weren't being reflected.
Yep, that's right. It's a snapshot of your code right there when you generate it. That's absolutely right. We spent a lot of time to have extensibility hooks to understand when some of these things happen, but you'd have to do some work to make that work. But out of the box, you're right. It won't refresh. It's really meant to be a point-in-time issue. Collaborate over it, have a conversation about it, and then it's temporal and natural. Is the main design. It's what we were really trying to get done with that particular feature set. But thanks for that. That's good feedback. Okay, we got one more, and then I think I'm getting the hook.
It's me again, yes. The sequence diagrams that you were showing, are they in a format that could be possibly queryable by another program, or is it all visual?
No, it's XML.
It's XML?
Yeah. So both the visual is XML, and the metadata, let's see, on the sequence diagrams, it's all XML. Yeah.
Well, and let me throw some more out just so you know. There's actually an API underneath it that we've published documentation for, which exposes the UML metamodel of the diagram, and you can dig around in there too.
You can even copy it in MS Paint and reuse it. Good, huh?
So, hey, listen, I appreciate you staying here. I know I'm the last speaker between you, dinner, drinks. I really appreciate you staying here. Thanks a lot.